Okay, we are starting with the properties of definite integral. The first point to remember is when I integrate a function f of x, it will become a new function. Let me denote it by capital F of x. That means I integrated sin x, it became minus cos x. This is capital F x stands for the new function. So first thing, integral a to b f of x dx. That means what I'll do? First I'll integrate this. So I'll get the new function. In that new function, I'll put the limit. First I'll replace x by upper limit. Then I minus replace x by the lower limit. This is clear to everybody. This is the process of definite integral calculation. So what will be integral a to a f of x dx? First property. What will happen? I integrated the function. I got a capital F of x. I put the limit a to a. Naturally, upper limit I replaced. Lower limit I replace. Naturally, I'll get the answer as 0. So if you integrate from a to a f of x dx, your answer will be 0. Okay. Second, what will be difference between integral a to b f of x dx and integral b to a f of x dx? If you interchange the upper limit and lower limit, will they be equal, or what will be the change? Let's have a look.
A negative of each other.
Yes, this will be f of b minus f of a, and this will be f of a minus f of b. Do you agree with this? So they will be of opposite sign. So whenever I interchange upper limit and lower limit, a minus sign will come. That's what the property number 2 says. Is it clear to everybody? Property number 3. If integral sin x dx is minus cos x plus c, what will be integral sin t dt? It will be the same function only. If I change the letter x to t, the integration function will not change. So if I'm integrating a to b f of x dx, and if I'm integrating a to b f of t dt, if I'm integrating a to b f of y dy, will the answer be different or same? Let's see. When I integrated small f of x, it became capital F of x. When I put the limit a to b, it will become f of b minus f of b. Now you tell me. Integral of sine is minus cos. If it is x, it will be x. If it is t, it will be t. So integral of f of t dt will be capital F of t. Only the variable will change. The function will be same. If the sine became minus cos, here sine became minus cos, here also sine will become minus cos. When you apply the limit, what you will be getting? Same f of b minus f of a. Which means you can denote any letter for the variable to represent the variable. Which means the third property says integral a to b f of t dt will be same as integral a to b f of x dx. It will be same as integral a to b f of y dy. The variable can be denoted by any letter. Variable or the function, okay. Yeah, variable can be denoted by any letter. Okay. So this is an important property. Every time when I'm going to prove theorems, this property is going to be seen every time. Any letter you represent, no problem. You can replace t by x or y or dy, no problem. Is property clear to you? Now last property, last and final property. Fourth property says integral a to b f of x dx. That means you have a number line, let's say 2 to 7. You have a number 5 coming somewhere in between 2 and 7. It is same as integrate from a to c, add to it c to b. You can split the integral. Only condition is c should be a number in between a and b. So integral 2 to 7 f of x dx can be written as, take any number you feel like between 2 and 7. No need to midpoint anywhere. 2, you can say, let's say 6.5 f of x dx plus 6.5 to 7 f of x dx. Why did I write f of 6.5? To show you that any number you can put, but only condition is number should be between 2 and 7. Did you understand this many property? All the four properties are clear. Once again,
सर ये फोर्थ वाला समझा नहीं.
see, you are integrating from a to b. A number in between a and b is c. So I can split the integral a to c plus c to b.
Okay.
Clear? Is it clear?
Yes, sir.
Okay. Now another example. Look at this. I was supposed to integrate 0 to pi sin x dx. It is same as integrate 0 to pi by 4 sin x dx. Then pi by 4 to pi sin x dx. समझ में आया?
हाँ सर.
क्योंकि pi by 4 is a number between
Pi and 0
and pi. 0 and pi. Okay. So let's recap first. First property. A to a f of x dx. How much is that?
0.
Zero. Second property. If I interchange upper limit and lower limit, what would be my answer?
Minus. Negative.
Minus. Third property. If I interchange the variables instead of x, if I put t, or instead of t, I put y, what can you say about that? Will they be equal or not equal?
Equal.
Variables can be represented by any letter. Fourth property, I can split the integral. A to b f of x dx can be splitted as a to c plus c to b. It is like running from a to b. I ran from a to c to crest and then to c to b. The same thing I completed the running from a to b. It's like that. Only condition is c to be a number between a and b. Is this four properties are clear?
Yes, sir.
Yes, sir.
Okay. Do you want to write down
Done.
four properties? Please,
Yes, sir.
those are not written, please write. Properties of definite integral. Nobody will ask you the proof. There's nothing to prove in this. After I finish writing, tell me, okay? Okay, are you ready for the theorems?
Yes, sir.
Okay, right. Theorem 1. These proofs are important, but very easy theorems. Prove that integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. I'll explain the meaning of it after I prove it. Okay. So at present, don't worry about the meaning, only just proving you have to understand. Remember, always the proof is by substitution method. So any integration, definite integral proof is by substitution method. This all to remember, nothing else. If one word remembering, this much only. What should be substituted? Either left hand side, if you are taking x can be replaced by a plus b minus t. If you are taking right hand side, a plus b minus x can be replaced by a single letter t. It is easy to take right hand side, so I start from right hand side. Stop writing, okay? Don't write anything because I have to make you write something more. Don't write now. Just look at it. One theorem you will observe. Remaining all theorem you can do yourself. Very easy to learn. We want to convert this into a single letter x. Therefore, a plus b minus x is replaced by a single letter t. What is the next step I should do? Dx should be removed. To remove dx, I need to differentiate with respect to any one of the variable, let's say x. I differentiated with respect to x. That is minus 1 equal to dt by dx. So when you cross multiply, instead of dx, I can replace minus dt. So instead of dx, I will replace minus dt. Instead of a plus b minus x, I'll replace t. Something more I have to do. What I have to do more? Anything more? Can I start replacing now?
Limits change.
Limit change. Very important. When x takes value a, t will take what value? A plus b minus x. So a plus b minus a, which is b itself. When x takes value b, t will be a plus b minus b, which will be a. So now my right hand side became, instead of a, it will become b. Instead of b, it will become a. Instead of a plus b minus x, it will become t. Instead of dx, it will become minus dt. So much is clear? Remember, I want this as answer. This minus that you see, I'm removing it outside. Now apply your first property. What property you can apply? Minus sign can be removed by
interchanging the limits.
Interchanging the limit. So I can write this as a to b f of t dt. Right? But my answer should be f of x dx, but I'm getting f of t dt. Now we can use the next property. What is the property we said? Variable can be represented by any letter, whether t or dt, no problem. You can replace a to b f of x dx. So it does not matter what is the letter will be used for variable. Only thing, limit should be changed, same, function should be same, then the definite integral value would be the same. The variables are not affected by it, hence it is equal to RHS, LHS. Did you understand the proof? All of you understood the proof?
Yes, sir.
Can you write down yourself?
Yes, sir.
Anybody, any difficulty? No. Okay, so let's try to write the proof ourselves. Okay, I'm removing this. Because I want you to by heart the proof today itself in the classroom. Did you make a note saying that method is substitution method?
Yes, sir.
Okay, then start with the right hand side, RHS. RHS equal to. Starting from right hand side. A to b f of a plus b minus x dx. I told you it's substitution method. Because it is substitution method, so you will say put a plus b minus x as a single letter, because you can see this should be converted to a single letter. But don't use x again, then you will get confused. So put some other letter. Now differentiate with respect to x. Minus 1 equal to dt by dx. So dx is minus dt. So dx will be replaced by minus dt. Then for changing the limit, when x takes value a, t will take value a plus b minus a, which is b. When x is b, t will be a plus b minus b, that is a. Then you can write, therefore, right hand side will become b2a f of t into minus dt. Now the minus will go outside. Now you will interchange the limit. Now here we need to mention the property. Since integral a to b f of x dx is minus b to a f of x dx. This mentioning this is very important in board exam. You don't mention the direct 1 mark. And third thing, what you say, last step, what you're going to say, you can represent the variable by any letter. So a to b f of x dx. Since a to b f of x dx is same as a to b f of t dt. Variable can be represented by any letter. And that is equal to LHS. Understood? Very simple, no?
Yes, sir.
Can I change the page or should I wait? Okay.
Done, sir.
That. Now do yourself. Theorem number 2. Prove that integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Do it yourself. So from where should I start?
RHS.
RHS. Integral 0 to a f of a minus x dx. What should be the substitution? What should be substitution?
A minus x equal to t.
A minus x equal to t. Do not write x again. You have to use some other letter. This is only one mistake students do. Some of them will write a minus x equal to x. Then you will get confused. So minus 1 equal to dt by dx, differentiated with respect to x. So dx can be replaced by minus dt. Now change the limit. When x takes value a, t will take value 0. When x takes value 0, t will take value a. Exactly a duplicate of what you did before. Because in the textbook they are given this as 2 different theorems, so I am also did it 2 different. Actually, both are same theorems. A to 0 it will become f of t into minus dt. Now remove the minus outside. Now change the upper limit and lower limit. Write the reason for it. Write the reason for it. Integral a to b f of x dx is minus integral b to a f of x dx. Don't forget to write the reasoning. Yeah? Now, lastly, the variable can be represented by any letter, whether t or dt, no problem, or a or. So it became f of x dx. Since integral a to b f of t dt and integral a to b f of x dx are same. Anybody has a doubt in this? Please tell me. I can explain with an example.
No doubt, sir.
No doubt. This from t f of how this t has been replaced by x, is it clear? Variable is. Do not think I'm replacing t by a minus x. The variable letter can be denoted by any letter in a definite integral. That's all is the method we are applying. We are not bringing back to x this x. We are only just changing. If suppose it was sin t dt, it becomes sin x dx. So because both have the same answer in the definite integral. Now we come to the application of this. Surely one application of this problem will be there in JEE, MHCT, and board. This is the most important application. Can I start?
Yes.
All of you
Yes,
ready? Okay. Suppose what is the difference between f of x, f of a minus x, f of a plus b minus x? Let's try to understand. Suppose I am writing x square plus 4x, the function. What do you mean by f of a minus x? Wherever x is there, replace it by a minus x. What is the meaning of f of a plus b minus x? Wherever x is there, replace it by a plus b minus x. Is that clear? So the difference between f of x and f of a minus x is x के जगह पे a minus x डालना है. So whenever I want to say replace x by 5, I'll write f of 5. Whenever I want to say replace x by sin x, I'll write f of sin x. So this notation is basically tells you what should I substitute instead of x. Our theorem says if the limit is from a to b, what can you do? It says wherever x is there, you can replace it by a plus b minus x. For example, pi by 6 to pi by 3 sine square x. It is same as pi by 6 to pi by 3. Limit is not changing, limit is remaining. In place of x, I can replace by add both of them, a plus b minus x, add both of them, pi by 2, 30 plus 60 is 90, minus x dx. Did you got the idea? X can be replaced by a plus b minus x, a plus b minus x. And that became pi by 6 to pi by 3 cos square x. Did you understand? Is it clear?
yes, sir. Yes, sir.
Which means if you are integrating pi by 6 to pi by 3 sine square x, if you are integrating pi by 6 to pi by 3 cos square x, both will give me the same answer. Clear? I hope all of you understood this application. Okay. Now we go for this. Integrate 0 to pi by 2 sine square x dx. Okay. The limit is 0 to pi by 2. So wherever x is there, x can be replaced by a plus b minus x. If you add both, how much you'll get? If I add
Pi
0
by
and
2.
pi by 2. So pi by 2 minus x. So what this became? 0 to pi by 2 cos square x dx. Any doubt? Sine 90 minus theta is cos theta. This is your equation 1. This is your equation 2. What I am going to do is I'll add 1 and 2. My left hand side became 2y. My right hand side will be 0 to pi by 2 sine square x dx plus 0 to pi by 2 cos square x dx. We have distribute the integral. I can take integral common also, no? So I'm trying the integral common. Sine square x plus cos square x. Chalega? Are they both equal? This both are they equal?
Yes.
Yes.
Yes, sir.
Now, how much is sine square theta plus cos square theta?
1.
1. I told you, you don't need big integral in this chapter. Integral of 1, x.
X.
Replace x by upper limit. Replace x by lower limit. You got pi by 2. It is a value of 2i. So I is how much? Pi by 4. Did you understand the first problem?
Yes.
Like this,
Yes.
there are plenty of problems. You have to think, whenever I have a limit, you have to think, if I replace x by a plus b minus x and then add both, will I turn to 1? Wherever it turns to 1, your answer will be upper limit minus lower limit divided by 2. This will be your answer. Wherever it turns to 1. Did you got the idea? When I add f of x with f of a plus b minus x, I should get the answer 1. If I am getting the answer as 1, then my answer is upper limit minus lower limit divided by 2. This is a shortcut in this exercise. And 90% of the problem works with the shortcut. Is it clear? Have you written?
Yes, sir.
Okay. Now I am going to show you another problem of the same kind. Okay. Integral pi by 6 to pi by 3. Did you notice that pi by 6 and pi by 3, if you add it, become pi by 2? Sin x divided by sin x plus cos x. So what I can do, wherever x is there, all the x can be replaced by a plus b minus x. That is pi by 6 plus pi by 3 minus x. 30 plus 60, 90. So pi by 2 minus x. So wherever x is there, all the x can be replaced by pi by 2 minus x. When I do that, what will this function change to? Don't write for a minute. Shagun, what the function will change to?
So cos x upon
This will become cos x.
cos x. Cos
This
x.
become cos x. This will
Sin
become sin x. Did the denominator change?
No.
No. This is a trick to understand that this method can be applied. You have to check. When I replace x by a plus b minus x, I'm going to write it now. Pi by 6 plus pi by 3 minus x. Only first problem we'll do like this, all steps. Upper limit, lower limit, you added, minus x. Upper limit, lower limit, if you add, all the x's will replace, not all, one of them. Wherever whole function, wherever x is there, all x should be replaced. And you can write this reasoning since a to b f of x dx is a plus a to b f of a plus b minus x dx. This is a formula you're applying. Now this will become pi by 6 to pi by 3. Sine 90 minus theta cos theta. Cos theta and sine theta. This is your equation 1. This is the equation 2. Did the denominator change? Sin x plus cos x and cos x plus sin x are same. Denominator did not change. So naturally, when I add both of them, what will happen? Denominator
One
is 2.
bun jayega.
1 minute. Denominator is 2. This is 3. This is 5. If the denominator is same, I can add the numerator. You agree with this? If the denominator is same, I can add the numerator. So what will become? Bolo, bolo.
1.
1.
1. So that is the way you have to recognize it. Before you start the problem, you have to think this mentally. Pi by 6 to pi by 3 sin x upon sin x plus cos x plus cos x upon sin x plus cos x. I did not write the limit separately. I did it together. So next step, it becomes 1. You don't have to write too many steps. Just understand that. So 2i is pi by 6 to pi by 2 sin x plus cos x divided by sin x plus cos x. That is pi by 6 to pi by 2, 1 dx, pi by 3, yeah? Pi by 3. Pi by 3 it is 1 dx. That is x from pi by 6 lower limit and pi by 3 upper limit. So upper limit minus lower limit is your answer for 2i. So I will be upper limit minus lower limit divided by 2. So 60 plus 30 is 30. 30 divided by 2 is 60. Sorry, this is how much? 60. 30. So pi by 12 becomes your answer. LCM 2 pi minus pi. So pi upon 12 upon 6. Then divided by 2 becomes 12. Is it fine? Pi by
Yes, sir.
12.
Yes, sir.
Yeah. So you can say your answer before you start. Once you decided that I plus I is going to give me 1, immediately your answer is upper limit minus lower limit divided by 2. This is your answer. So you can predict the answer before you start. Clear? That is why this problem keeps on coming in MCQ, because you don't have to spend any time. Just look, recognize the method, you will get the answer. Is it okay? Let's practice few problems more so that you recognize this. Okay. Write this question. Verify integral a to b f of x upon f of x plus f of b a plus b minus x dx is equal to how much? Can you tell me the answer?
B minus A upon 2.
B minus a upon 2. So start with the left hand side. Let I is equal to a to b f of x plus f of a plus b minus x. So the property says wherever x is there, all the x can be replaced by a plus b minus x. Replace this x also by a plus b minus x. Replace this x also by a plus b minus x. So wherever x is there, all x has been replaced by a plus b minus x. This and this will get cancelled. So it became a to b f of a plus b minus x divided by f of a plus b minus x plus f of x. So equation 1 and 2 have the same denominator. Both of them have same denominator. So when you add 1 and 2, then 2i, limit will be a to b, numerator will be f of x plus f of a plus b minus x. Denominator will be f of x plus f of a plus b minus x. I cut down the steps directly. I added and wrote. In the exam, you can also do that. Got the technique? Now let's check whether you can recognize these problems in the exam. Okay? Can I change?
Yes, sir.
Yes, sir.
Yes.
I'm going to write few questions, so you should be able to recognize them. First one, integral 1 to 2, root x, root of 3 minus x plus root x dx. Another example. Okay. So what happens? What you can replace x by what?
A plus
A plus b. What is a plus b here?
3.
3.
3 minus.
So if I replace 3 minus x, 3 minus x, 3 minus x, and add I plus I, will I get 1?
Yes.
Yes.
So we'll do this. So let I is equal to, so replace all the x by 3 minus x. Write the reasoning since integral a to b f of x dx is integral a to b f of a plus b minus x. This is a reasoning. This reasoning is important. You must write it. 1 to 2 root to 3 minus x in numerator, root x plus root 3 minus x. Equation 1, equation 2, add 1 and 2. So 2i is equal to integral 1 to 2 root x plus root 3 minus x upon root x plus root 3 minus x. So 2i is equal to integral 1 to 2 1 dx. 2i is equal to x from 1 to 2. 2i is equal to 2 minus 1. I is equal to 1 by 2. This will come in MCQ. So when it comes in MCQ, don't spend your time calculating all this. Just you have to check I plus I, will it give me 1 or not? If it gives you 1, upper limit minus lower limit divided by 2. Done?
Yes, sir.
Okay. Now one more I'll give you practice. Integral 0 to pi by 2. 1 upon 1 plus root of tan x. Does it belong to this category? Before you start, mentally calculate. If I replace x by pi by 2 minus x, what this root tan x will change to?
Cortex.
Cortex.
Cortex. But we want the function to be in only in tan. So wherever you got root cortex, you can write it as 1 upon root tan x. When I take the LCM, will it change? Now check. 0 to pi by 2, 1 upon 1 plus root tan pi by 2 minus x. That became 0 to pi by 2, 1 upon 1 plus root cortex. That is 0 to pi by 2, 1 upon 1 plus 1 by root tan x. Cortex can be written as 1 upon tan x. Now take the LCM. root tan x plus 1, and LCM will go to the numerator. Now add 1 and 2. So you express whatever the answer you got, expressed back in tan. When you add 1 and 2, what will happen? You get 2i, 0 to pi by 2. Denominator both are same. So denominator both are same, so numerator will get added. So you will get answer again as 1. So it became x from 0 to pi by 2. So pi by 2 minus 1, pi by 2 minus 0. So I is pi by 2 divided by 2. So hence answer is pi by 4. So there are plenty of questions of the same kind. Only you need to recognize them. Now let me go to your textbook and select the questions. I've got very less questions over there. Where's the textbook exercise? Okay. Are you ready now?
Yes.
Yes.
Yeah. Slightly different question. Integral 0 to a 1 upon x plus root of a square minus x square. Does it belong to this category? If I replace x by a minus x, will I come back to the same denominator? This denominator would become a minus x. This will become a square minus a minus x. Anyhow, it will never turn. Whatever I do with this, it will never turn back to this original. So this method cannot be applied here. So then what is a method that you can do? Think about a definite idea. Whenever I come across root of a square minus x square, whether it is derivative or integration, use the same technique. Can anybody tell me?
X equal to S and theta.
Very good. Put x as, excellent. Put x as a sine theta. Put x as sine theta. So differentiate with respect to theta. So dx becomes a cos theta d theta. Change the limit. So my new variable is theta. Theta is sine inverse x by a. For why did I make theta as a subject? Because I have to find theta's value. So when x becomes 0, theta became sine inverse 0, which is 0. When x became a, theta became sine inverse a by a, which became pi by 2. So I can write now the integral as 0 became 0, a became pi by 2, and dx became a cos theta, x became a sine theta, root of a square minus x square became a square minus a square sine square theta. Actually, that is the reason why to remove the root only we are putting x as a sine theta. Is it clear? Now this became 0 to pi by 2, a cos theta in numerator, a sine theta plus, taken a square common, 1 minus sine square theta. That became 0 to pi by 2, a cos theta, a sine theta, a root of a square cos square theta, that became a cos theta. Now the a will get cancelled by taking common. Now this problem became I plus I by that problem. Cos theta upon sin theta plus cos theta. Now replace theta by pi by 2 minus theta. Right? And that became 0 to pi by 2 sin theta upon cos theta plus sin theta. So this is one of the problem which we already did. This is 2, this is 1. When you add 1 and 2, 2i became, can I write 0 to pi by 2 1 d theta? No need of spending my time on that. Theta from 0 to pi by 2, no problem now here.
No.
So 2i became pi by 2. Therefore, I became pi by 4. Is it clear? So don't write off this answer as a minus 0 by 2. Don't write your answer as a by 2. That is wrong. After substitution only, it becomes upper limit minus lower limit divided by 2. This is a problem to be noted. Most likely question for the exam. They'll put some number here, 5-year, 25-year, and do the problem. Are you ready for next one?
Sir, 1
Yes,
minute.
sir.
Yeah, take your time. Take your time. No hurry. Mark this question important. Most likely question for 3 marks.
Done, sir.
Done. You are going to try yourself next problem. 0 to pi by 2 log tan x dx. Okay, let's do it mentally. Who is the student who will help me out? Sridhar?
Yes, sir.
Yeah. So replace x by pi by 2 minus x. So tan will become,
Cot. Cot.
when you add, what will happen? 2i. Which two terms will get added? Original function log tan x and the new function log cot x will get added. Right?
Yes, sir.
Now next step, what it will become? Of course, integral is there. Integral is there, 0 to pi by 2, everything is there. But you have to really just think about this. What this will become?
So it will be multiplied.
Log tan x into log m plus log n. How much became? Tan into cot is 1.
1.
And log 1 is how much? Log of 0. So your 2i is 0, hence answer is 0. Did you get the idea?
Yes, sir.
This way, mentally you have to calculate before you start the problem. Then only you can recognize whether it's an indefinite problem or a definite problem. The other method. Okay, start I. Wherever x is there, replace it. Log of tan pi by 2 minus x. So till now, I was having all problems with 1 as coming, but it is not necessary every time it should be 1. So this problem, one problem I have completed in fact. I am taking the questions which do not come 1. That became 0 to pi by 2 log of cot x dx. Equation 1, equation 2. Add 1 and 2. So 2i is 0 to pi by 2 log of tan x plus log of cot x. That became 0 to pi by 2 log of tan x into cot x. So 2i is 0 to pi by 2 log 1 dx. 0 to pi by 2, 0 dx. So 2i is 0. Therefore, I is also 0. So when can we apply upper limit minus lower limit divided by 2 method? Only when I plus I gives you 1. If I plus I does not give you 1, then we cannot apply that shortcut method. Ready?
Yes, sir.
Okay, do this problem. Integral 0 to 1 log of 1 by x minus 1 dx. Please do it yourself. Mentally first. What will write this as? Take the LCM. That will be easy to understand. Okay. Now replace x by how much? One speak out, one of you.
1 minus x.
1 minus x. So just mental calculation. This x will become 1 minus x. This x will become 1 minus x. Everybody understood now how 1 minus x? Upper limit. 0 plus 1 is 1 only. So it became log x upon 1 minus x. If you add this both, what will happen? Log 1 minus x upon x and log x upon 1 minus x. If you add, how much will become? How much this became?
1 log
1.
1.
1,
Log 1. And log 1 became how much?
0.
So answer is
0.
0. Clear? This
So,
way mentally, yes.
so integral of 0 should be a constant, no? Because derivative of a constant is 0.
Integration means summation. 0 is not a constant. Derivative of constant, yeah. Okay, I'll tell you. Derivative of constant is 0, right? So integral of 0 is a constant. But after integration, if you put upper limit minus lower limit on a constant, what will happen? C minus C, okay, 0 ho jayega na?
Huh.
That's why it becomes always 0. Integral of 0 will be a 0. Or in other words, integration means add. Summation, yes, summation. So when you add 0 how much ever times, you'll get 0 as answer. That's why integral of 0 is 0. If you think this way also, no problem. If you think this way also, no problem. Your answer is 0.
Thank you, sir.
Okay, yeah, very good question. Okay. Now let's replace 0 to 1 log of 1 minus x on 1 minus x. X is replaced by a plus b minus x. That is, x is replaced by 1 minus x. So 0 to 1 log of x upon 1 minus x. This is equation 1. This is equation 2. Question is I. So add 1 and 2. So 2y is 0 to 1 log 1 minus x upon x plus log of x upon 1 minus x. Zero to 1 log 1 dx. 0 to 1, 0 dx. So your answer is 0. So 2i is 0. So I is 0 by 2. Next one. Are you ready for next?
Yes, sir.
Yes, sir.
Okay. Integral 0 to pi by 2. Sin x minus cos x divided by 1 plus sin x into cos x. So limit is 0 to pi by 2. Immediately think of replacing x by pi by 2 minus x. Do it yourself. So what it became? Mila, answer Mila.
0. Yes, sir.
What is the answer?
0.
Ah,
0.
good. So denominator is same. So you can add. So when you add, since the denominator is same, you can add the numerator. Sin x minus cos x plus cos x minus sin x. So 2i equals 0 to pi by 2, 0 dx. So 2i is equal to 0, I equal to 0. Can I go to next?
Yes, sir.
Yes,
Okay.
sir.
Now another type I'm teaching. Till now we were doing either 0 or I. If the limit is 0 to a and you have x to the power n, a minus x to the power a fraction, then what to do? Okay, I'll give an example. Every number it cannot work. I just want to show you when an integer is here and a fraction is here, how to go about. Example, integral 0 to 3 x square into 3 minus x raised to 5 by 2. In this problem, nothing like I plus I. There's a direct problem. You are allowed to replace x by how much? X can be replaced by
3 minus x.
3
minus
minus
x.
x. So I'm going to replace by 3 minus x. Now you will notice very interesting. The powers will get interchanged and then p by q will get interchanged. 3 minus x will have power 2 and x will have power 5 by 2. So basically what happens here? This x will become a minus x and this a minus x will become x. The powers gets interchanged. What is the benefit of it? I could not expand 3 minus x because power was a rational number. But now I can expand this 3 minus x. 9 minus 6x plus x square. So this power should be a small number, otherwise this expansion would be a tedious job. Now I can open the bracket and integrate. So 9 x raised to 5 by 2 minus 6 x raised to 7 by 2 plus 2 plus 5 by 2 will become 9 by 2. Has everybody understood this? Opening the bracket, powers are added. 5 by 2, 5 by 2 and 1, 5 by 2 plus 2. Now integrate it. X raised to 7 by 2 upon 7 by 2. 6 into x raised to 9 by 2 upon 9 by 2. X raised to 11 by 2 upon 11 by 2. Limit is from 0 to 3. Now this I can write as 18 by 7 x raised to 7 by 2. This is 4 by 3 x raised to 9 by 2. 12 by 9, 4 by 3. 2 by 11 x raised to 11 by 2. Now I'll replace 3 here. 18 by 7, 3 raised to 3 by 2. That means 9 root 3. Correct? No? 2, 6, 6 and a half. 6. Oh, no. 7 by 2 is how much? 3.5. No? So 3. Okay, let it be. 3 raised to 3 cube root 3. 3 raised to 4 root 3. 3 raised to 4 root 3. Root 3. Remaining zeros. So take root 3 common and calculate. 18 into 27 by 7. 4 into 27. Plus 2 by 11. So 77 is LCM.
Sir, the last 2 by 11 term is x raised to 11 by 2. So it should
Oh,
be.
yes, dear. I got confused with my own handwriting. Oh, here. So this will become 11 by 2 means 3 raised to 5 root 3. 3 raised to 5. 9 into 3. 81 into 3. 243. 243 into 2. 486 by 11. Big number. It's better to take 3 raised to 7 by 2 as common instead of taking 3 root. Okay, no problem. I'm taking 27 common. So 8 by 7 minus 4 plus 27 common. So 9. So 2 into 27 into 3 square upon 11. 9 into 2, 18.
So first term is also 18 by 7.
18. So 27 root 3. 77 is LCM. 18 into 11, 198. 4 into 77, 308. 18 into 7, 126. Very big calculation. They are given a very bad number in your book. This is a textbook problem. 27 root 3. Adding this both, how much you'll get? 66. 16. 16. 126. 16. Oh, that's a bad question. 27 and 16 you multiply and write. But if it was 0 to 1, it would have been easy. 0 to 3, that's why it became very difficult to calculate. Once like this, why did I do this problem is, based on this, there was a JE question. If you know that this powers get interchanged, then you could answer that question. That's why I did this problem. Are you ready? Yes, it's okay. That calculation is not much of importance. Are you ready for next?
Yes, sir.
Yes, sir.
Yes, sir.
Integral 0 to 1. This question can be asked in two ways. So first method, I'm giving you the longest method question. This is also a JE question. This came around 4 or 5, 6 years back. It came in actually advanced first, then it came in main. Okay. Looking at this, it's difficult to recognize what to do. But one hint you will get, 1 upon 1 plus x square is the derivative of tan x, tan inverse x. So what you do here is, put x as tan theta. So theta is tan inverse x. So d theta is 1 upon 1 plus x square into dx. So I can have this at d theta, this x as tan theta. Now change the limit. When x is 0, theta is tan inverse 0, which is 0. When x is 1, theta is tan inverse of 1, which is pi by 4. So this I became 0 to pi by 4 log of 1 plus tan theta into d theta. In the board exam from here, the question is this. JE, this is a question. Board exam, they'll ask you from here onwards. Okay. It is difficult for us to recognize what method to apply unless and otherwise you have done this before once. Instead of tan theta, you write tan pi by 4 minus theta. Do you agree with this? Theta can be replaced by upper limit minus x. This theta can be replaced by a plus b minus x. Now, what do you do? Now give the expansion of tan pi by 4 minus theta. So 1 minus tan theta upon 1 plus tan theta. Any doubt? Any doubt here?
No, sir. No, sir.
Now take the LCM. One plus tan theta plus 1 minus tan theta upon 1 plus tan theta. This got cancelled. Can I rub this side?
Yes, sir.
So this became 0 to pi by 4 log of 2 upon 1 plus tan theta. Now you are in a position to add. This was your first equation. This is your second equation. Adding 1 and 2. So 2y is equal to 0 to pi by 4 log of 2 upon 1 plus tan theta plus log of 1 plus tan theta. I purposely wrote those together. That became 0 to pi by 4 log m plus log n log m into n. So it became only log 2. Now log 2 is a constant, so it goes outside. 0 to pi by 4 1 d theta. So your answer, once it become 1, upper limit minus lower limit become log 2 into theta from 0 to pi by 4. So 2i is pi by 4 log 2. Therefore, I is pi by 8 log 2. Mark it very, very, very important. It can come in everywhere. Board exam, anywhere. A part of it can come in board exam or it may come direct. So we'll continue with more problems in next class. So I'm going to give you some MCQ questions on this topic. Also some questions on this topic. Okay. Wherever MCQ is there, whichever you can make I plus I as 1, directly you can write upper limit minus lower limit divided by 2 and write the answer. There are problems where it doesn't turn to 1. We'll have to make it in this format and then integrate. Okay.
Yes, sir. Yes, sir.
Yes, sir.
Can I do one more problem or should I do it next class?
One more.
One more.
Okay. Little lengthy problem. Are you ready?
Yes, yes, sir.
0 to pi by 2 sine square x upon sine x plus cos x. So this is also a problem where it doesn't become 1. So what I do first is replace x by pi by 2 minus x. I can do this I plus I method as long as denominator does not change. When I replace x by pi by 2 minus x, denominator does not change. So I can do I plus I, but it will not turn to 1. That's all difference in this problem. So sine square pi by 2 minus x upon sine pi by 2 minus x plus cos pi by 2 minus x. That becomes 0 to pi by 2 cos square x upon cos x plus sin x. Because the denominator is same, you add. So 2y is equal to 0 to pi by 2. Denominator is same. Numerator became sin square x plus cos square x. So 2y became 0 to pi by 2, 1 upon sin x plus cos x. That's all we can do by definite integral property. Now we have to use indefinite method to solve this. Tell me two methods to solve this problem.
Multiply, divide by root 2.
Very good. Another method.
Half
Reciprocal.
angle formula.
But little more better way of speaking is tan x by 2 is t. One method is put tan x by 2 as t. Another method is a sin x plus b cos x can be written as root of a square plus b square into sine of x plus alpha, where alpha is tan inverse b by a. Remember this?
Yes, sir.
You can use that. So sin x plus cos x becomes root 2 into sine x plus pi by 4. Then you can integrate. This is one method. Second method is put tan x by 2 as t. Which method do you want to do? Which method do you want me to do?
Tan x by 2.
Okay, tan x by 2 is t. Anything will do. There's nothing difficult, which you can remember. That's all is the idea here. Okay, putting tan x by 2 as t. So dx will be replaced by 2 dt upon 1 plus t square. Sin x will be replaced by 2t upon 1 plus t square. Cos x will be replaced by 1 minus t square upon 1 plus t square. Limit will be replaced. When x is 0, t is 0. When x is pi by 2, t is 1. Tan pi by 4 is 1. Quite fast you can write. Left hand side is 2y. So 2y is equal to 0 to 1. 2 dt upon 1 plus t square. 2t upon 1 plus t square. 1 minus t square upon 1 plus t square. So the denominator will get cancelled. 0 to 1. 2 upon 1 plus 2t minus t square. How to solve this one?
Perfect square.
Complete the square. But t square's power is negative. So 1 minus t square minus 2t plus 1 added inside, added outside. 2 minus t minus 1 the whole square dt. Now you can use the formula 1 by 2a log of a plus x upon a minus x. So 2 into 1 by 2a log of 2 plus a, na, a is root 2, t minus 1, root 2 plus minus t minus 1. When I put t as 1, this becomes 0. When I put t as 1 here, this becomes 0. Minus log root 2 minus 1 upon root 2 plus 1. Log 1 is 0. Very lengthy problem. Log 1 is 0. So minus 1 by root 2 log of root 2 minus 1 upon root 2 plus 1. So I is equal to 1 upon 2 root 2. I'm taking this minus as a power. Log of root 2 plus 1 upon root 2 minus 1. If you feel like you can rationalize this, log of root 2 plus 1 the whole square. So 1 by root 2 log of root 2 plus 1 is your answer. You could have done by the others root 2 sine pi by 4 plus x also. You will get same answer. This is a little lengthy problem. Once it came in board exam, very long back. Nowadays they don't ask such big problems. Just I wanted to show you that I plus I always don't give you 1. Sometimes you'll have to integrate by indefinite method and get the remaining part. That's why I asked. Similar type came very, very long. In 70s, it came in JE question, JE advanced question. 70s, that is the beginning. If you look at very beginning questions are all your classwork problems. So in 70s, IIT JE was not that tough. But slowly what happens is the question once comes in IIT JE, then it becomes a problem of your test book. And then slowly by slowly, the level keeps on increasing. Today's IIT JE problem and 70s JE problems are much different. Okay, we'll stop with this much.
Yes, sir.
Okay, I'll send you questions on the